We will continue our discussion on functions by talking about composition of functions. All right. So now we know what functions are. Now what do we do with them? Okay. Let's look at some examples. First of all, let's say f1 is a function from the set of real numbers into the set of real numbers, and maybe f2 is another function from the set of real numbers into the set of real numbers. Okay, so if we take a point x from the set of real numbers, okay, f1 of x, so f1 of x is a real number, right? It's from here. The same is true for f2. f2 of x is another real number. Okay, so these two are real numbers, and for example, we can add them. All right, okay, no problem at all. We can add them, but now, so this addition makes sense for any x. So effectively, what we did is we constructed a new function. Let's call it f1 plus f2. Okay, so we have this function f1 plus f2 that's defined on real numbers with values into the set of real numbers. Okay, f1 plus f2 of x is just f1 of x plus f2 of x. No problem at all. We were just lucky that the set of real numbers has an addition on it. Okay, so we were able to add these two functions. So while we actually did get something new, we didn't get it just because of something special happening in between f1 and f2. We only got it because of the properties of the real numbers. Okay, we can also do a multiplication in between these numbers, right? So we can say f1 of x times f2 of x. Okay, and this will define another function. We can call it f1 times f2. All right, so we have another function f1 times f2 defined on the set of real numbers with values into the set of real numbers. Okay, f1 times f2 of x is f1 of x times f2 of x. And again, so this is another function, well, based off of f1 and f2, but essentially we were able to do so just because of the fact that the set of real numbers has an addition and a multiplication, and we can continue to do so, right? Okay, so this is fine, but this is not what functions introduce. Okay, the essential property of or operation on functions is the following. Okay, think about okay, what happens if we've got a set A, okay, and we've got another set B. Okay, and we have a function f defined on A with values in B. All right, so what functions do is they take points from A, so let's say A from capital A gets taken by f into this point f of A. All right, so this is what f does. What happens if we've got another set here? Let's call it C. Okay, and we've got another function g from B into C. Okay, so now this function g knows what to do with this point f of A. So this point here gets mapped in a point in C. Okay, well, okay, so A got mapped in here into a point that we called f of A. Now this point f of A gets mapped by g into this point. So how should we call this point? Okay, well, the natural name for it is, because it's taken by g, so it's g of what? Of the starting point, g of f of A. All right, so actually what we got is we went from A to C. So from A, we made it into C by hopping through B. All right, and eventually we got to the conclusion that A gets mapped into this point whose natural name is g of f of A. All right, so effectively what we did is we constructed a new function whose natural name is g composed f. Okay, and this function g composed f is defined on A okay, and it takes values into the set C. And the definition of it is G composed F of A is G of F of A, okay? And this is what's called composition of functions. Okay, so one thing we need to remember is that in order for us to compose two functions, it's got to be the case that the B, which is the codomain of F, is equal to B, which is the domain of G. Okay, we can tweak this condition a little bit, but for now, this is what we need to remember. In order to compose two functions, G and F, it's got to be the case that, so in order for G composed F to exist, it's got to be the case that the codomain of F is equal to the domain of G.